Well, that's a refrigerator, but how does it work? How does a refrigerator work? I'm glad you asked. Actually, it all starts with the bike pump. Have you noticed this when you're pumping up your tyre, running late for school? The whole thing gets very hot. You can't feel it now, although I can, in the palm of my hand. You're about to see what's happening. I'll take a little tuft of cotton wool and I'll put it over the bulb of this thermometer. And then I'll pump the bike pump onto the bulb of the thermometer. And if there's any temperature change, you should be able to see it. See that red line? That tells us what the temperature is now, and it's just about 20 degrees Celsius. I'll pump a few pumps and look what happens to the red line. Up, 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 up. It's up to 25, 26 and still rising. Because what's happening when you pump a bike pump or any other sort of pump is you're pushing molecules closer together. You're compressing them. When you compress things, you get a heating effect. What happens if you do the reverse? Well, every time you take a spray can, air freshener, or deodorant, or fly spray, what you're doing is starting with something that's already compressed. Those molecules are tightly packed together, and you're releasing them, and they are evaporating. The pressure is being released, and when that happens, you get a very different effect with the thermometer. Watch this. Same thermometer once again, and it's back to, just above 20, where it was to begin with. And we'll give it a blast with the air freshener. I'm aiming it at the bulb. Watch what happens to the red line. Now, you see what's happening? It's coming down, down, down. It's down to about 15 and still coming lower. And it'll keep on doing that as long as I keep giving it a blast with this, because as the molecules come out and spread further apart, we get a cooling effect. You get the same sort of effect when you let air out of a tyre, either your bike tyre or a car tyre. Have a look at this. Here's a car tyre, and it's pumped up tightly. I'm going to release some air by just pressing the matchstick on the valve, and I'll try and direct that stream of air onto the bulb of the thermometer. Once again, you see if you can see what happens to the red line. Are you ready? There it is. It's a little bit above 20 now, and down it comes slowly, slowly. In fact, it's already dropped about 2 or 3 degrees. And as long as I let that come out and hit the bulb of the thermometer, because the molecules are spreading further apart, we get that cooling effect. And this is the same sort of cooling effect that allows a refrigerator to cool your food. We can make a model of a refrigerator with 2 of the things that we've already looked at. The bicycle pump and the spray can. We'll place this at the bottom of these plastic tubes there. That's the compressor. Imagine those plastic tubes are connected to the bike pump. That can actually push molecules closer together and give you a heating effect. Up here, we have something that allows evaporation to occur. So we'll say the spray can represents the evaporator in the refrigerator. Now we've seen that when evaporation occurs, we get a cooling effect, and when compression occurs, we get a heating effect. So the coils on this side will be hot, and the coils on that side will be cold. And we get continual circulation of some sort of fluid. And that's exactly what happens in a refrigerator. It's not a circulation of air or water or methylated spirits or any common liquid. It's something called a refrigerant. There are a number of them. One of them is called Freon. Well, let's see if we can see any of those parts in our refrigerator. We open it up there. Maybe you've noticed this before. The bottom of the freezing compartment has ridges. That's because there are coils. There are little tubes actually going up and down on the floor of the refrigerator. Underneath there is the evaporator, something like the spray can, that's allowing a liquid to turn into a gas, to evaporate, so we get a cooling effect up in this region and in fact through the entire refrigerator. What about those other bits? Well, for those we'll need to turn around and look at the back of the refrigerator, the bit that you don't normally see. When we do, we find that right down here underneath is a compressor, very much like that bike pump. It's pushing the fluid around continuously in the refrigerator, and what it does, of course, is to push molecules closer together, as well as keeping them circulating. These tubes at the back of the refrigerator are very important, and they're also quite hot, and it's those that allow the heat that's brought out of the inside of the refrigerator to escape. So all of those parts are very important. If we look at a freezer over here, that's had the wall cut away, you can see both sets of tubes very clearly. The inner set of tubes are the tubes that are close to the evaporator, and it's in those that you get a very cold fluid circulating, and heat is taken away from the food, which is just inside that thin wall. On the outside, here are the tubes where compression has occurred, and so these are quite hot, and the heat is allowed to escape through the thin outside wall of the freezer. Between the two sets of tubes, of course, there's a thick layer of insulation, so that the hot tubes don't make the cold tubes hot again. And here's another freezer, which also shows us the two rows of tubes. The inner ones, you can see they're made of copper, well separated from the outer ones by a layer of insulation. So, how does a refrigerator work? Well, very much like a bike pump connected to a spray can.